Good morning. Today's mini lecture is going to focus on how to count the number of atoms in a compound. So before we do that, we need to go back and do a quick little review. We have two different types of numbers. We have what is called a subscript and we have what is called a coefficient. The subscripts are going to be the small numbers that appear within the formula, and those subscripts are going to appear because of either the crisscross method in the ionic bonds or the sharing of electrons reaching the magic number of 8 in the covalent bonds. But the subscript numbers do not change. They are always going to stay the same, so we never mess with any of the subscripts. Now the coefficient number is a larger number, like in this example, that appears in front of the whole entire compound. So coefficient numbers are going to be used whenever we start balancing equations, and that's going to be our next unit, how to balance equations. So before we go into balancing, let's just make sure that we have some of the fundamentals. Let's just make sure that we can count the number of atoms. So in this first equation I have Na2SO4. Now the whole point is not being able to count just the total number of atoms, but it's to be able to count the number of each individual element within that compound. So in this case, what I would do, and this is the procedure I'd like for y'all to follow as well, we're going to write underneath the compound, we'll write the symbols of the elements that appear in the compound. Now if you notice this, many of y'all already picked that up, SO4 is a sulfate, polyatomic ion, but I'm going to break it down into the individual elements of sulfur and oxygen. So now I can just simply look at the coefficients. I have 2 of my NAs, I have 1 sulfur, and I have 4 oxygens. So as we were going through and doing molar masses, we already have done this. Next thing I want to do is I want to look at what happens if you have a subscript that is outside of a set of parentheses. Same thing as counting the elements. We're just going to go through and write down the elements that are going to be involved. We have Mg for magnesium, we have the phosphorus, and we have the oxygen. So now when we look at this, same thing, I'm going to come back up here, I'm going to look at the subscript. I have 3 magnesiums. So I'm going to put a 3 right here. This time I do have a phosphorus, and I have 1 of them, and I have 4 oxygens, but you see how that's in parentheses? Just like in math class, we are going to distribute this 2 through the parentheses. So that would mean that I would have 2 phosphoruses and 8 oxygens. And that's how I would go through and count those. In our last example, we have both subscripts, we have parentheses, and we have coefficients. So not any more difficult, very easy math, but we need to go over it just to make sure we understand how to do the distribution property. So I'm going to go back in, same thing. I have aluminum, I have carbon, and I have oxygen. So in my aluminum, I have a subscript of 2, but this time do you see how I have a coefficient number? If it is a coefficient number, a big number in front of it, it's distributed all the way through the compound. Not just through, like in this one, this was only distributed through the parentheses, but this coefficient is distributed through the entire compound. So this time I would have 6 aluminums. Now when I come back over to my carbon, I have 1 carbon here, but I have a 3 outside of the parentheses, so it's going to be 3 carbons, but I still have to distribute that 3 as well, so that's going to end up with a total of 9 carbons. So now we want to finish up with our oxygens, and we have 3 times 3 because it's distribution, so that's 9, and then 9 times 3 more is 27. So you can see that sometimes you're going to get quite a few atoms within those individual compounds. So this is going to be the procedure. This is also the setup for how I want you to go about counting the atoms for me to begin with. So you wouldn't just come up here and say, a total of 7 or any. Instead, we divide it up: sodiums, sulfurs, oxygens, 2, 1, and 4. So I hope this has helped you. We are going to be using this in our next activity, which is preparing to balance equations, which is doing nothing more than counting atoms. So have a good day.